So let's continue with embedding. Okay, like one of the most interesting parts of the whole learning process was that, okay, what's the embedding? Machine can't understand uh, the words, the picture by itself. So that's why firstly it and divide it with tokens, like it divide it multiple chunks. For example, in words um it will be tokens, and in the pictures it will be something like pixels. In the white and pixel, like multiple chunks. In the voice method it will be the same. Then so and then it transfer into the every token transfer to the number. No, so it transfer to the number, then create a vector which explain the meaning of that word. For example, we have, how we can say, like there was a good example actually. Okay, then just do the same, that kind of stuff. Yeah, I will explain. So like it gives the vector, and for example, like it is the woman vector and it is the man vector. The difference is actually the gender. Yep. So when it comes to the king vector and the king, and when it comes to the the queen should be somewhere here, because the difference also the gender, like here. So it means, for example, from vector of king you can add, like in the vector of king you can add the woman and just uh, get it from the man, then we have the queen vector. So machines do the same stuff. Okay, machines do the same stuff, but in the ChatGPT or other models, large language models, they use that technique, like they firstly embedding it, and then, okay, actually, for example, when we just have vector of that one word, and there will be it's static. It calls it's the it just represent its meaning, not how many something like letters on it or another stuff. Just it's represent meaning of that word, but it called static embedding. Like it is, and there is no other the effects of other stuff. But when we like in the ChatGPT, like when you give the question, it gives the answer. But how it works, uh, it continue your how your word with probability, like which word is highly like can be there, and it gives the which word can be there in gives the one of the like highest probability of that word, and like every single time it do the same thing. It use probability to guess the word, and it continue with that. So but uh, for example, it's not just enough using static embedding. You have need more, like it was called contextual embedding. Maybe you have this. No, this we don't have. Like for example, contextual embedding. Like for example, we have this. Here's like in the static embedding, but it adds other vector values um, of this stuff. Like why it adds? Because of having contextual meaning, like contextual embedding of this for this vector. So after adding this, we can have it. Like it help to like it make more easier to predict the next word of after the dish. For example, dish can be like just it can be like meal, or it can be something like plate. After saying rice dish, like you can predict it is for sure meal. In Indian, you can predict like how you can find what kind of Indian and sweet Indian rice dish it is. For sure, it's something like here, here. It's work like that. So after that, it we have to need the order of the words also. For example, it can be 0 to 1, 0 to 2, 0 to 3, like, and we need the order, like we need the positional embeddings, because positional embedding help us to predict also the next word, because it is like make it easier, like where it is. Attention head, attention, there will be the multiple attention heads, like for example, one attention head like give you information about is it how is it work. So in the attention head, you can have multiple, like for example, you see how it affects the adjectives of it. Like we need adjective or we need word version. The next, like it also helps to predict the next word by like how kind of like the other meanings, like widely research, widely learn the world, and widely learn the step and sentences, how it is, how it works. I mean, like how it is. For example, it is noun. Okay, then the next word can be the noun or other stuff. Like it calculate the probability of it, how it can be. Then we had feed forward network, like it's also do the multiple thing. So here there it is encoding. This part is encoding. It's decoding. Okay, Google. Let me just go ahead with feed forward network. After the feed forward network, we can have the last part of it, and so feed forward network Future do widely how maybe like we can widely go with is each vector with each dimension, like there will be multiple dimensions. For example, maybe in the ChatGPT there is 12,000, maybe something like that. It was um, so it goes with every part of every dimension and calculate the probability, like dive into. So it's encoding, it's decoding. ChatGPT has both of them, but for example, Google don't have decoding. Cause so input embedding, like we have embedding, then positional encoding, multi-head attention, like it's do attention head, like multiple attention head, all of them, and normalization. After that, multi-head attention, we can have, for example, like we add, like we subtract, we do something that kind of stuff. Then instead of that, we can have, for example, 8 or minus 3. We just it in the normalization part, it just have in a scale of maybe in a -1 or 1 or 0 to 1. I think like 0 to 1, and feed forward, and also normalization, and it goes to the output embedding. so so it's also that kind of stuff, but the only thing it differs, after it we have softmax. Actually, softmax is also having that stuff in a 0 to 1 scale, and also there's temperature, like this softmax. There is temperature, yeah, which is help us. For example, when t equals to 0, it gives the result, like it choose the word in the, like it choose the word which is the highest probability. But when we give like other stuffs, maybe you can increase it, and when we start increasing and using it, it can there is possibility of giving the words which doesn't have as much as as much as highest probability as other words. For example, some words have, like in here, the word of the code here has highest probability, but when t is not zero, it can give you something that another uh, biryani maybe. It's not sweet. It's meal, other meal, but it's not the sweet meal. So it can give that because it doesn't matter. Biryani have less probability, but because of the probability of it, like will maybe increase, and I mean like it shows like that, then the machine can get that word. So every single time the ChatGPT goes through every these steps and gives the output probability, like which words have most probability of using it, and also choose that word and print it, and also go back again, like go back into input and do all the stuffs. So nutshell, it works like that. Um, yeah, in the whole embedding Transformers and Transformers 2, it was, yeah. There is like more. We can dive into the more multi-head attention and feed-forward network, but neural network stuff. But in a nutshell, they will like that. So thank you.